Good day, everyone. I am Elaine C. Pineda, a student at Dominican College of Tarlac, and particularly from STEM to the Mater Salvatoris. Our lesson for today is all about derivation of reciprocal identities using super hexagon. But before we start the lesson, what is super hexagon and how it is drawn? Are you ready? Let's begin! The superhexagon for trigonometric identities will help us to create a memory trick on how to learn the reciprocal, the cofunction, Pythagorean, even odd, and quotient identities. It is a simple hexagon that will look like this. All we need to do is join all the opposite vertices, and that will give us 3 diagonals. Then, we write 1 in the center. It is difficult for us to believe that this one hexagon can lead us to many formulas. To know the formulas, I would like to present to you the 6 function names to each of the 6 vertices. Remember, there is a certain way in which we need to write it. We start writing from this vertex, go around the hexagon, and end at this one. It's easy, right? We just draw a hexagon, join its opposite vertices, and write 1 in the center. Now let's see how we will write the 6 function at the 6 vertices. We just need to recognize the one formula which we have seen. It is tangent is equal to sine by cosine. I'd like to notify you that we have already used this formula over and over. Tangent is equal to sine by cosine. We start at this vertex. We write tangent, sine, cosine, in the clockwise direction. As you can see, we still have more 3 vertices remain. We write cotangent opposite to tangent. What remains is cosecant and secant. If we draw a vertical line through the center of the hexagon, we will now have 3 vertices on the left side and on the right side as well. So, to remember what's written on this vertex, notice that they all have functions, and starting with c on the right side, we write cosecant here, and what remains is secant. That's all we need to recall on how the superhexagon has to be drawn. Now, we will talk about the main topic, derivation of reciprocal identities using superhexagon, which I discussed previously. Let's redraw the hexagon with 1 in the center. We write tangent, sine, cosine, cotangent opposite to tangent, cosecant here, which all this is on the right, and what remains is secant. At this time, let's focus on the function at the diagonally opposite vertices. Sine and cosecant, cosine and secant, cotangent and tangent. They are reciprocal of each other. Look at this arrow for instance. It tells us that sine theta equals 1 by cosecant theta. How about this one? It tells us that cosine theta equals 1 by secant theta. And last, this arrow tells us that cotangent theta equals 1 by tangent theta. If the arrow is drawn like this, we can even say that cosecant theta is reciprocal of sine theta, even secant theta reciprocal of cosine theta, tangent theta reciprocal of cotangent theta. Be mindful of the fact that functions at diagonally opposite vertices are reciprocal of each other. I just want to add this idea about the topic. Tangent equals sine by cosine, or tangent equals secant by cosecant. Another one, tangent multiplied by cotangent equals 1, or sine multiplied by cosecant equals 1. And last, cosine multiplied by cosecant equals cotangent, or sine is the reciprocal of cosecant. These are the following methods to follow on how to solve the reciprocal identities. That's all I want to share with you all. Thank you for your time and attention today. Again, I'm Elaine C. Pineda from STEM 2D Mater Salvatoris.